Okay, so welcome back. We're going to do a part 2 video here of section 4.2 on annuities. We're going to take a look at an example, do some computations with this stuff. Um, the first example we're going to take a look at is in the 4.2 slides, and the problem deals with a company that offers its employees a 401k plan and offers to match its employees' contributions at 10% for up to a $600 employer contribution per year. The first question that this will allow us to address is what will be the total monthly deposit she makes with employer contributions. So the way this works is that they say that they will match 10% up to $600 per year. So what that means is that if she's putting in $90, and this is per month, and she does this for 12 months, well, that comes out to a total of $1,080 total over the course of that year. Well, if we look at 10% of that amount, well, 10% of that is not $600. In fact, it's only $108. So the company will match, in this case, the full amount that she's putting in. So that means that every month, if she puts in $90, she's going to put in the full 100% of that $90, plus she's going to get 10% from her employer. So in whole, she's going to be putting in, or a deposit of $99 will take place. So again, $90, they're going to match 10% of whatever she contributes. 10% of 90 is $9. So she'll put in her 90, company will put in their $9, she'll put in a total of $99 per month. So an employee decides to use her 401k, she makes payments of $90 per month to an account that pays an average of 7% compounded monthly. If she retires in 30 years, how much can she retire on from this account? So 30 years, if it's compounded monthly, this will go from 0 to 360. Typically when we make a payment, we just draw a little box here at the bottom to span the full amount of time, because it's a constant payment of $99. So we'll put a negative 99 in there. This is, so we said 7%, so 7% is the rate compounded monthly, and now we can calculate. We can put in our, in fact you can do 30 times 12 here if you don't know that it's 360 months. You can put in 7% here. Now we're not told that she's making any lump sum deposit, one-time deposit, so we put that as 0, and she's making a regular monthly payment of $99. So the first payment is accounted for within this PMT. We'll calculate the future value, and we find out that she has $120,777.13. That's what she'll have in total after 30 years. Not very much to retire off of. In fact, very little. Especially when people are retirement age, they usually make the most amount of money they've made throughout their life. So that's how we address a problem like that. Let's take a look at one that has just a little bit more detail. Imagine that you start a retirement account. You believe you'll put in $30 from each paycheck. You get paid weekly. Initially, you put in nothing. Your retirement goal is to have $1 million so that you can live off of interest. If the average on a retirement account over the last 20 years has been 8.95% compounded monthly, will you accomplish your goal? So in number 3, we're going to take a look at the first part. And now, keep in mind, this is compounded monthly. So over the 240 months, 20 years, this person is going to put in $30 each week. Now, based on what we know about compounding, if a bank only compounds monthly, then the exact position of where the $30 was put in is not really relevant. In other words, the payment is a total of $120 a month. And that's really what the bank is looking at, because they're not paying interest on each of those $30 amounts. So we're keeping this kind of simple, assuming the bank doesn't treat each $30 payment separately. We're just bunching them up and saying over the course of the month she puts in $120. And so we want to know, over that 30 year at 8.95%, will she accomplish her goal of $1 million? Well, only one way to find out, and that is to get the future value. So 240 months at 8.95%. No present value, $99 or excuse me, this is negative $120, different problem, and we find out that she only has very, very little, $79,639.26. So the answer is no, she won't. In the next part, we're asked, well, you know what? How long will it take? So we'll call this part 1. Part 2, well, how long will it take? So what should this month be over here? Well, we want to accomplish $1 million, so we'll make sure that our future value is $1 million. All other things being equal, 1, 2, 3, 1, 2, 3, we want to know the amount of time that this will take. Now, we always round up, because keep in mind that you can't, your bank's not going to pay you. This is relying on interest being paid. Interest doesn't get paid almost towards the end of the month. It gets paid at the end of the month. So we would have to keep this in for 558 months, which I think is about 46.5 years. So really a long time if you're going to be making a small payment like this, even at a high interest rate. Part 3 says, well, you know what? Let's just say that we want to still keep the time frame the same. What would you need to put in each month to accomplish the goal? So if we were, instead of adjusting the time, we adjusted the amount of payment, what would that payment have to be to go from 0 to 240? What would the PMT be so that this all works out? So what would that guy be right there? And this is still at 8.95%. So we just have to kind of work in reverse again. We want to have $1 million here. We know that. So we know that we want to accomplish this goal in 240 months, because you know what? Some people only have a certain amount of time till they don't feel like they're going to be able to work anymore. So we'll calculate the payment, future value of $1 million. We'll calculate our payment, which is going to be equal to $1,506.79. So you have to chunk away a lot every month in order to accomplish this goal within 20 years. Now, one interesting aspect is, check out what happens if we just increase this by 10 years. So 360 months. That's 10 years later. Look at what happens to the payment. Look how drastically that's dropped. That dropped by 2/3 of its amount, roughly. This is because we say that we call it time value of money. And time is everything, because as time passes, you're compounding interest on interest on interest on interest. And that can get very, very big over time. So that's just a little side note, how much a 10-year period can make, how much of a difference it can make in terms of a payment. In addition, also, you're putting in payments for a longer period of time, so you don't have to put in as much. But the interest is the big kicker here. Further questions we want to ask is, how much principal have you put in? So this was the part 1 question. Part 2 question, well, you know what? You've put in $1,506.79 per month, and you've done this for 240 months. So that would amount to, this is kind of a by hand or a calculator computation outside of TBM Solver, 1506.79 times 240, and we find out that we get 361,629.60. So that's how much principal was put in by this individual. The next question, or the next part, well, I guess this is part 1. Forget it. We won't call these parts to confuse them. So this is part 3. We want to know how much interest have you earned. Well, keep in mind that the million is the full amount. That's principal and interest, what we put in and what we've earned. Well, if we take away all of the principal, then that means what's left is an interest amount. So that means that in total we'll have earned 638,370.2, I believe. I believe that's the amount in total. Put my commas in the wrong place. So this should be, no, that doesn't sound right. Oh, yeah, I did make a mistake here. This would be 0.60. So 361,629.60, and I'll do this real quick. 1, 2, 3, 1, 2, 3, minus 361,629.8, and I get 638,370. 0.2. for 0.20 cents. So that is a big chunk of interest, and that's a pretty good deal, pretty good earning over the course of time. It's $638,370.20. The last question we want to ask is, how much interest do you earn in the last 1 year? Well, this could be a tricky question. How do we figure out how much we earned in the last 1 year? So I'm going to draw a picture of the last 1 year. Now, this isn't going to be deceiving, but actually the 12 months before the 240th month is actually the 229th month. Because if I count month 229, I count month 230, 231, 232, 233, all the way up to 240, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 11 intervals, however, we're counting the 229th month. So counting the number of tick marks that I have to advance to get the 240th month, that's actually a total of 12 advances. So, well, I know my balance is 1 million at the time of retirement. That's according to the goal anyway. Well, what would I have after coming into the 229th month? What would be my balance coming into here? Now, we're not saying after the 229th month, we're just saying coming into it. So what I would do is I would figure out, okay, 228 months. If 228 months passed, how much money would be accumulated? Well, I would have $897,457.36. So that means over the course of the 1 year, it's grown to that amount. The difference is 1 million minus 897,457.36. I take the difference, I get 102,542.64, $102,542.64. So this is in last year. Now, we have to be careful. We can't just stop here and say this is all interest, because we were putting in payments here. Over this last year, we were putting in payments of $1,506.79. So we've got to actually subtract that out, because that was money that came out of our pocket. We don't want to think about that as interest, because some of it isn't interest. So we're going to take away our out-of-pocket, OOP, or the OOP. And we find out that we get $102,542.64 minus 12 out-of-pocket payments of $1,506.79 gives us a total interest of $84461.16. So that's how much we actually earned in interest over the last year. Now, you've got to be asking yourself by now, the tension, can you use the TVM solver to find the total interest earned over a smaller period of time? Of course, the answer is yes. We have a function in our calculator, in our TVM, in our finance app called int. Now, what the function inputs is, whenever you actually pull it up, it gives you the sum, int, and then a parenthesis. And it wants the beginning month of the interval that you want to know the total interest earned over, and the end month. And what you do is, so for example, ours would be, if we wanted to know over the last year, we would include the 229th month up until the 240th month. And we would notice that that should give us the pretty darn close to the exact same answer. Now, we've got to make sure we're in our home screen. So go to second mode, quit out of, if you're in TVM Solver, get out of it. Go into apps, go into finance, but don't hit TVM Solver, and scroll down until you see the sum int function. So there's sum int. I'm going to hit enter. It pulls into my home screen. I type in 229, 240, close parenthesis, hit enter, and notice, voila, there it is, 84461.11. A little bit of trouble here. 84461.11. Now, you might say, hey, that's different. Now, yeah, it's 5 cents off, but that was just because of rounding error. And depending on how you round, this could be a little bit more off, but it should be, there should not be more than, anywhere near a 1%, even a 1% error in the difference between the two numbers. So this is a quicker way to do it. Finally, we're going to look at a problem which has us consider, well, what if interest rates change? Like in this problem, when planning for retirement and opening up a 401k or 403b, which are simply names for annuities based on corresponding IRS tax codes, you have the option of choosing how aggressive you want your fund to be. The riskier you're willing to be, the more of the potential return, but the higher the risk of loss and major fluctuations. Suppose you open a 401k with your current employer and decide to contribute $300 each month. For the first 5 months, the average return is 8%, then 15% for the next 15 months. For the next 20 years, the rate remains fairly stable at about 7%. Assume the first two rates are, we're going to actually assume that they're all compounded monthly because we encounter a slight difficulty if we don't do that. Assume all rates are compounded monthly. Okay. So what we're going to do, the trick to doing these problems is just to do it carefully. Break up a time diagram into enough segments representing the different interest rates. So we know that for the first 5 months, so our payment is stable here at $300. So PMT equals negative 300. For the first 5 months, we earn 8%. So from 0 to 5, we earn 8%. From 5 to 20 for the next 15 months, the interest rate jumps to 15%. And then for the next 20 years, which is 240 months, so 20 plus 240 would put us at 260 months since the beginning, and this actually drops down to 7%. We want to assume that all rates are compounded monthly. How much will be in your 401k at that time? So what we have to do is basically do kind of a rollover, where each time the interest rate changes, we roll over our whatever our current future value is, add a regular payment to that, and let it accumulate. So here's what I'm talking about. Go to Apps, Finance, TVM Solver, and we'll enter in the first period of that 8% is paid over. So 5 months, 8%. No initial money is being deposited. No extra lump sum of money is being put in by this person. Like I said, they had $1,000 lying around. Well, then we would have negative 1,000 here, but we don't. Our payment is 300, so negative 300. So after 5 months, at compounded monthly, this will be worth not very much, $1,520.13. Now what we're going to do is we're going to roll that over along with the new payments. We're going to treat this as a present value. For the next 15 months, at 15%, we're going to have a present value of negative 1520.13. Because this money is technically still an outflow, the bank's keeping it, though we don't want to just ignore it because it's being used again in addition to us making more $300 payments. So notice both these are negative because they're both still outflows. And after 15 more months of this, we would have $6,747.40. Again, we roll this over at the new interest rate. This is going to be for 240 more months. So 240 more months at 7%. Present value is the negative 6747.40. Regular $300 payments taking place over this interval. The future value after the 240 months would be $183,528.98. And that's our total amount of money. Well, I think, and this is sometimes called a reinvestment problem, just FYI, because the money is sort of, quote-unquote, being reinvested every time the interest rate changes. So that's it. Check out the homework. Let me know if you have any questions, and take care. See you next time.